All right, welcome everyone. Now, today I'm going to walk you through the complete explanations to um, the May-June 2020 Cambridge International A Level paper 3. The syllabus code is 9709, paper 33. Now, in this case, you may want to use the MF19 to refer to any formula required there. All right. Okay. I'm going to uh, just scroll through so that you can see. All right. Total marks is 75. All right. Okay. Let's look at the first question. Okay. Now this first question is inequality. Um, Now the inequality state that this modulus is greater than that. Okay. Now there are many ways to solve this, of course, right? Now, one more safer way to solve this is by um, using a bit of visual illustration and algebraic um, manipulation here, right? Now, I'm going to show you this method here. Now, first of all, I'm going to sketch. I get a rough sketch of this graph here. So I'm going to sketch it aside here. Get the axis done. Okay. Okay. So that's our axis, and then I'm going to get this first graph. So that is um, x plus 2. So x plus 2, 3 times of that. Okay, so 3 times of that, x plus 2. Okay, x plus 2. Okay, I'm going to draw this graph here. X plus 2 graph. X plus 2 graph would be something like this. You can see that x plus 2 is basically, oops, sorry. X plus 2 graph actually looks something like this. Okay, hold on, just let me get that done. X plus 2 graph. So this is x plus 2 graph. Okay, and then now this is x plus 2 alone. It's not the modulus itself. So its modulus will look something like this. Okay, just to show you one more time. This is y equal to x plus 2. Okay, it passes through a 2 and then here a negative 2. Now that's how it look like. Now if you want to achieve the modulus graph, you will have to flip this up. So I'm going to flip this up here. So it's going to look something like a rough sketch. So it will look something like this. And then I will have to erase this section here. Okay. And then there you have it. This graph will be a modulus graph. X plus 2 modulus now. Okay. And then three times of this modulus graph. So you're wondering how that graph actually look like. Now, of course, you can take a few values to figure that out. So at x equal to negative 2, 3 times of that will still stay as 0, right? Because the y value is 0 itself. Okay, then you can try this value here, the y-intercept, for instance. Okay, so when x is equal to 0 here, the whole value become 6. Okay, now this is not drawn to scale, so to 6 here. All right, so therefore you can see that this is something like a stretch. It's a stretch in the y direction. It's a stretch in the y directions there. All right. So therefore, the graph should look something like this now. Okay, so roughly I'm going to draw it down here. Hold on, I'm going to draw a dotted line here just for me to refer. So therefore, the graph will look something like this now. Okay, it will look something like this. Oops, I'm using the wrong tool here. Sorry about that. So the graph would look something like this now. You can see that it's going up, and then this one will be something like this. Okay, so roughly this will be this graph would be y equal to, okay, just let me get that done. Yeah, this graph will be y equal to 3x plus 2, like this. Okay, so I hope that give you an idea what sorts of transformations occur here. Okay, now we have done getting that graph. Now the second graph, 2x minus 1, is quite easy because there's no stretching involved here. Now this graph basically passes through a -1, so it passed through a -1 here. Now of course, and then it also passes through a half. Yeah, it also passes through a half. Therefore, this graph would look something like this. Okay, so originally it should be it should look something like this originally. Okay, uh, but because it's a modulus graph, so it should look something like this now, I assume. Okay, I did not draw to scale, so it should look something like this now. Okay, so I hope that is clear. All right, now I'm going to erase off this section here. Sorry, erase off this section here and this section. All right, so the graph will look something like this now. Okay, I don't need these sections anymore. Okay, I'm going to erase that off. I will call this the y equal to 2x minus 1 modulus here. Now, because it's a mess here, I'm going to clean up everything so that you can see what we are looking at. So we only have two graphs left after all the transformation. So it should look something like this now. We don't need this anymore. Okay, we don't need this anymore. All right, maybe a slide. Yep. So there you go. This is how the graph will look like. I'm just merely estimating that it could be intersecting at this point. And finally, oh yeah, there's only two intersection point there. Sorry about that. There are only two intersection point. Okay, so that will be quite easy to determine here. So you have two intersection point. All right. So this line here is not there. Let me correct that. Oops, sorry. Okay, so that's how it looked like at this point. Mhm. All right. So once you knew visually how the graph actually looked like, now solving this would be much more easier. Now, most of the time when we solve a modulus graph, if you are able to draw it, it'll be easier. If you are not able to draw it, that is fine. I'm going to show you another method. We're going to tally the methods shortly. Okay, so by using the first method, is a visual plus algebra. Okay, now this red graph here, has two sections. The first section here, the graph can be written as y equal to, um, I would say, negative 3x negative 2, right? Because there's a negative component of that, all right? And then this section here is y equal to 3x plus a 6. Oh yeah, I forgot the 6 there. So this part's supposed to be a 6, not a 2, sorry. Hold on, just let me clean that up. I forgot to multiply the 6 there. So that is a 6. All right. I hope that is clear. All right. And then as for the blue graph here, this section represent, because it's a negative gradient here, so this represent negative 2x plus 1, whereby this section here represent 2x minus 1. Now I hope that is clear. Okay, this one here is, what do we have here? Half. I forgot to label that. All right, now I hope that is clear. So in order to obtain the intersections for A, for instance, in order to get the intersection for A, okay, let's find intersection at A. Okay, at A intersection. All right, all you need to do is just solve these two simultaneous equations, which means negative 6 is equal to negative 2x plus a 1 there. So from here you get an x equal to negative 7. So this is actually negative 7. Okay, and then next, in order to figure the intersection, so find the intersection B. So find the intersection B here. We are going to solve for this equation and the other equations there. So which means it's negative 2x plus 1 together with the other one, which is 3x plus a 6 instead. Right? So from here you have 5x equal to negative 5. So therefore x is actually equal to negative 1. All right, we are almost done. We are almost done. We have found the intersection point. So from here, all we need to do is identify the region where the blue graph, okay, the region where the blue graph is above. This greater than means above the red one. So let's see where the blue is actually above. So the region. So you can see that it's between A and B. Between A and B, the blue is actually above. The blue is actually above. All right. Other than this region, the blue is always below now. The blue is always below. So therefore, we can conclude that the solutions to this inequality would be, okay, the x must be lying between negative 7 and negative 1 there. All right. Now I hope that is clear at this point. We just need to identify the region where the blue line is above the red. It's quite clear in this case. All right, now we are done. We are using visual and a bit of algebra. It takes a bit of time, but it helps you to recall a bit on transformations and drawing graph. Okay, so I hope that's been useful. Next, I'm going to show you second method. Second method, how we can solve this without using visual. Okay, this might be some of your favorite, right? Purely algebraic methods. So to do this algebraically, okay, to do this algebraically, we can actually square both sides. Okay. Now bear in mind, if you square both numbers itself, you have to make sure that the condition of the inequality remain the same. Yeah, remain the same here. Okay. So in this case, we're going to square both sides. We will have something like this. That will be a 9, a square there. Right. So from here, all you need to do is just go through the normal expansion. We have 4x squared, 4x plus 1 greater than 9x squared plus 36x plus 36 there, right? And then after that, you're going to simplify that. So that will be a 5x squared. Hold on, so let me see. So there will be a 5x squared, and then that will be a 40x, and then finally I have 35 less than the 0 there. So that will be x squared um, at x 7 less than 0, 7 and a 1 are less than a 0. So you can see that this inequality is less than 0. Now, from one inequality, it turned into another inequality. All right. So therefore, how do we solve this inequality? Of course, you can. There are two ways to do this. All right. You can either sketch this graph. You're going to sketch this graph here. Okay. You must make sure there is a region of this graph, part of this graph, that is below the x-axis. Okay. So I'm going to sketch this extra graph here. It should look something like this. And then the graph would look something like this. Because it's -7 and -1. So -7, -1 here. We are looking for a region of this graph that is below the x-axis. So below the x-axis, therefore, the x must be lying between here. Therefore, we can conclude that, all right, now the solutions for this is actually x greater than -7, less than -1. Now, that is how we secure the solution. Now, the second way is by using line number graph. If you are not a fan of the graph itself, you can always draw a line number graph like this. Okay, for a line number graph, all you need to do is identify the x-intercept or the roots. So in this case, we have the x-intercepts -7 and -1. It looks very similar to this. It's just that we don't actually sketch the shape of the graph because the shape is not important in this analysis. All you need to do is try and error. For instance, you can choose a value that is greater than -1, for instance, 0. Let's put the 0 into here. So 0 into here, you get a 7 times 1, which is positive. So you label that as positive. And then you can try out any numbers between -7 and -1. You'll find that it's a negative sign, less than 0. And then finally, you'll find that that is another positive. Now, what we want now, instead of looking at the graph, we are looking for any region that is less than 0, negative. So therefore, you can see that, yeah, it would actually give us the same solutions that we need here. Right? Now, I hope that is clear for your understanding. But a word of advice: whenever you use square methods or any other methods you want to introduce left hand side and right hand side, you have to make sure that the inequality remain in the same direction. Yeah, then you can apply that strategy. So here I have already shown you 3 different methods how you can actually solve this inequality using different tools at your disposal. Right? Okay, now I'm going to move on to the second questions. All right, let me clean this up. Okay, second question. All right. Now, second question is integration questions, which not many of us are fancy of this. Okay. Now, of course, you have a very advanced calculator. You can just key in and then get the answer. You you will always ask this very simple yet very important questions. Why do we need to um, perform this manual integration if we have a very advanced calculator then? Okay, my personal answer to you is yeah, go ahead with your advanced device there, right? It's just for the exam purpose. They want to check for your um, understanding whether you are able to integrate it manually and then show your skill in the integrations plus the computations part. They could have um, written down a much detailed guideline as to what is actually expected from the students itself. But normally we are all trained to actually carry out what we are supposed to carry out. Okay, if we see this question, right? Now find the exact value. Okay, which means it can be in the third form, in the irrational form, and so on. All right. Okay, let's try this out. Okay, there are many rules involved in integrations. Okay, I can't even remember which rule to use at this point. Okay, so you can either use start off from the simplest one. Can I use the simplest one? You found that yeah, it's kind of tough because there is a x involved, right? To make it easier to analyze this, I always would do it this way. I would use divide and conquer strategy. I would actually write it down like this. Okay, I'll write it down like this. Yeah. Now you don't have to include the lower bound and the upper bound at this point. I'm just trying to obtain the indefinite integration first. Okay, divide and conquer. Check whether you are okay with this. Now, at least to a certain extent, I know how to integrate this. I know how to integrate this. This is quite simple to integrate, right? Now, that is basically negative e negative 2x, like this. Okay. Now, to show you how do I actually obtain this, of course, that is too fast, too furious. So the proper way is follow the rules. It'll be negative 2x divided by the coefficient for the x, which is this. All right. And then from here, we can simplify that. You will end up with negative e negative 2x. I hope that is clear. Now, the second part of this, we will need to use, because it is a product of u and v. So it's better to use integration by parts. Integration by parts. All right. So integration by parts. I'm going to write down. Use a big bracket here. So integration by parts. That depends on which one you want to integrate and which one you want to differentiate. Usually, we will tend to choose the term that is um, that's able to reduce after we perform differentiation. So take for example exponential. Exponential is kind of uh, a very extraordinary function, I would say, because it's e. Yeah? Okay, it does not go through a lot of transformation. So therefore, the rule of thumb is we always choose um, e exponentials of to be integrated. To be integrated. So here we will choose e to be integrated. X is the one that we're going to differentiate there. Now, I'm not going to use the formal notations to work with this. I'll just write down the formula directly. Later on, I'll show you how the formal formula actually look like to reach here. So the direct formula looks something like this. and then I'm going to differentiate this. That is a 1. Right, so that's how it actually look like. Okay, right. I hope that is clear. Now, next, of course, some of you are wondering how do I actually came up to here then. Okay, this is how it looked like. So you are going to let your u and v here. Okay, so take for instance, you will let your u equal to an x, and then your dv dx. Your dv dx is equal to exponential negative 2x. It's always u and dv dx there, right? So from here, your du dx is a 1. Du dx is a 1. And then from here, we are going to get our v. Our v is the integrations of this. Integration of this. And then the x e negative 2x dx integration is actually given by uv minus, okay, minus, what do we have here? Minus v du dx dx integration. Now that is the formula for integrations by parts. Okay, so from here, all you need to do is just substitute this. You can see that the u is a x, the v is e negative 2x dx minus of the v is this. Okay, so from here you get negative 2x dx. All right, and then du dx is a 1. I did not show my 1 here, so dx. Then finally you have the last integration. Of course, most of the time at A level, you don't want to have double integrations. That looks more complicated in this case. So therefore, you tend to simplify these integrations to be negative e negative 2x over a 2. So from here, instead of writing this, we could have changed it to this instead. Let me show it to you how it look like. So we could have changed it to this instead. Therefore, the u is x and v. Okay, so that will be negative x e negative 2x over 2 plus, because there's a negative there. So plus, what do we have for v? Plus e negative 2x over 2 dx integration. Yeah, because this is 1, so v is this. We just need to put it in like this. And then there you have it. The whole section here. If you are not very familiar with these notations, by all means, you can use this instead. So I'm showing you a various way to actually solve this integration by parts. So in this case, we can actually write in this way, negative x e negative 2x over 2 plus e negative 2x over 2 dx from here. Okay, so that's how it would actually look like at this point. All right, I hope that is useful. Okay, next. So from here, we can simplify now. From here, you get negative e negative 2x. This will be a plus half e negative 2x over 2 minus of half e negative 2x dx. Okay, we are almost there. And then, of course, we can finish off this integration here. So we can finish off these integrations. It will become 1 over 4 exponential negative 2x. Okay, and then of course you notice that this term and this terms are a like term, so therefore you can actually join them together. Then that will be like a 5 over 4 e negative 2x plus half x e negative 2x. And then lastly, of course, as a conclusion to this definite integration from 0, 1 here, okay, now that would simply be this one here. Zero, 1, and then that's it. Okay, so from here all you need to do is just substitute a 0 and a 1 inside. So if I were to substitute a 1, I would end up with 5 over 4 e negative 2 plus half e negative 2 also, subtract off with a 0. So if you substitute a 0 here, this one must be a 0, and then this one will be a 1, so there is subtract 5 over 4. And then finally, of course, these two are like term, so 2, 7. So that will be 7 over 4 e negative 2 minus 5 over 4 there. Of course, some of you fancy factorization. You can always write as 1 over 4, 7 e negative 2 minus a 5. And then that will be our final answer there. Alright, now I hope this has been a clear explanations to your learning. I hope all of you will be able to integrate this quite easily. Okay, and there you go. That's the answer. Okay, now done. Okay, next we're going to move on to question 3 now. Okay, question 3. Right, now here we need to show that the equations can be expressed as a quadratic equation in term of exponential x. Okay, now up to you. I would always prefer divide and conquer strategy here. Like this is one piece, you can always bring them into take them to the other side. Yeah, other side. All right. Okay. So from here we will be able to have e negative x is actually equal to negative 2x in this case. All right. Now I hope that's clear. We're going to perform anti-logarithmic in this case. So that's how we end up with this. And then of course you would like to get rid of this negative. If you are not very familiar with this negative, you can always write like this instead. Maybe writing this will be more familiar to you instead of using negative. Okay, now to get rid of this exponential, that will be e to x then. All right, and then this part will be ex, and then of course finally I'm going to transfer that over. Okay, now that's how we can express the quadratic equation here. Sorry, the logarithmic equation here as a quadratic equation in the exponential form. Maybe this, this, or this. Okay. Now, does it look like a quadratic equations in ex? Yes, it does. So instead of looking at this, we can write like this. So if it does not look quadratic to you, we try to mask it out. So we let y equal to ex instead. Therefore, this would lead us to equations number 1 here would turn into y squared plus y minus 1 equal to 0. Alright, now this is a quadratic equation embedded with exponential. Okay, I hope that is clear. Now in the exam, I think most of the time you just need to show this two-step to indicate that this is a quadratic equation in the form of EX. All right, now I hope that is clear. We're gonna move on to B now. Okay, now hence we're going to solve this. Now we have managed to write our exponential quadratic equation as such just now. So we're going to solve this. To solve this shouldn't be a problem. We have already let y equal to ex in this case. So therefore we have y minus 1 here. All you need to do is use a bit of your quadratic equations here. That will be 1 square plus a 4 or 5. Yep, there you have it. Okay, now that will be our answer. And then, okay, this is very important. Okay, I need to make a remark here. The y must be greater than 0 because it's exponential. Therefore, because y is greater than 0, therefore there's only one y that we can choose from here, which is -1 plus cert phi over 2 here, and then we know that y is not the final answer that we are supposed to look for. That is y. So from here we have to write out ex. Ex is supposed to be equal to -1 plus cert phi divided by 2. And then finally the solution. So the x will be ln -1 plus cert phi divided by 2 here. Okay, so from here, of course, you need your calculator on that. Okay, let me get my calculator. Okay, let me get my calculator at the side here, so that it's not. Okay, does it run? Okay, my calculator is not working properly. Oops, I think the calculator is not working properly here. Something wrong with the calculator, I think. Is it working? Oh, it's not working. Just let me reset that. Okay. Okay, give me a while. Let me reset that. We should be able to obtain the computations for this value here. So there's a ln -1 plus square root of 5 divided by 2. Is that correct? Yep, that is correct. Okay, so from here, we found that the answer is -0 point something. All right, but we need to leave the answer to the nearest 3 decimal places. So therefore, I need to set this to 3 decimal places. That will be 481 here. 3 decimal places. All right, I hope that is clear. It's quite a easy peasy lemon squeezy question. The only catch is this section here. You have to remember, because there are two value. Exponential can only accept 1, which is more than 0. All right, I hope that is clear. Okay, I'm going to move on to the next one now. Okay, question 4. The equation of a curve is given by as such. We need to find the differentiation. Whenever we deal with an inverse of a trigonometry function, it's always best if we can apply implicit differentiation. So let me show you how to perform implicit differentiation as a revision. So here the y is equal to x tangent half x here. So we can write that as this, step by step. Okay, and then there you have it. And then from here we can write that as tangent y over x is equal to half of x here. Okay, now things will become very interesting at this point. Okay, it become very interesting at this point. Right? So now, first of all, we are going to um, now up to you how you want to deal with it. All right. For me, I would actually differentiate this tangent y over x as secant, because tangent will transform into secant first of all. Yeah, that's the first step. Okay, that will be the first step. And then thereafter, you have to differentiate the internal structure here. So therefore, we have to differentiate the internal structure. So differentiating the internal structures um, is very challenging because it consists of a y here. Yeah, it consists of y here. All right. So that is the tough part. So I'm going to show it to you anyway here. So you can apply a quotient rule for differentiating this if you want. So that will be like, if I'm applying a quotient rule here, so that will be x dy dx minus of a y over x squared. Okay, that's how it look like. And then what I did was I'm actually differentiating. Okay, just to show it to you what happened. I'm actually differentiating both sides here with respect to x. So by differentiating both sides with respect to x, my right hand side will be easier. Sorry about that. Just let me clean this up. This is a bit messy here. So this would become d dx half x. This is just a fancy notation to state that I'm trying to differentiate this expression with respect to x. That's all. And then that is simply just a half. And then from here, all you need to do is just need to do a bit of manipulations here. So take for instance secant. Secant is 1 over cosine. Now therefore this whole thing minus y, the numerator over x squared must be the same as half cosine square y over x. And then from here, you can slowly rearrange them. For instance, dy dx minus y is equal to half x squared cosine square y over x. Okay, and then lastly your dy dx. So here, take a bit of shortcut here. Lastly, there will be a y divided by x plus x over 2 cosine square y over x. Okay, this is one way how we can differentiate that. Okay, I think after I have performed these operations, right, no one would like to uh, learn about differentiation anymore. Okay, right, now just for your reference. Okay, I'm going to write down my answer at the side here for checking. So I'm going to write that down as a way to check. So dy dx is actually equal to y over x here. And then plus x over 2 cosine square y over x there. Okay, now that's the method that I have applied. Now, of course, there are other methods that you can use. For instance, uh, for instance, in this case, you can let say for instance you can let z equal to tangent inverse x over 2. Yeah, we can do that here. From here, you will have tangent z is equal to half of x. Okay, and then by differentiating this with respect to x, for instance. So by differentiating this with respect to a z, we will be able to obtain this. Okay, now this tangent would become secant z and then dz dx equal to a half. And then from here, your dz dx is actually equal to half cosine square z there. Okay, now that is the differentiation of this, right? And then you will notice that z is actually equal to the inverse here, and then you notice that the tangent z is equal to x over 2. We have cosine square here. Okay, now how do we work out the what do you call that? How do we work out this in terms of uh, x then, for instance? This is in terms of z. If you want your answer in terms of x, what should you do? Okay, now this is the way to do it. Okay, we're going to use a trigonometry identity. 1 plus tangent is equal to secant square theta there. Right. You notice that this is tangent square z must be equal to secant square z. Now this is our secant square z. Therefore, our secant square z is equal to 1 plus a square of tangent. So which means this is over 4. Now that is our secant square z. Then therefore from here, instead of writing cos itself, you can actually write it down as 1 over 2 secant square z, which is the same as 1 over 2. Your secant square z is 1 plus x squared over 4 here. And then therefore, we will end up with, here you can reduce this as it's actually a half, like this. And then if you want to decorate it more, in this case, it will be 2 4 plus x squared. And then that is the differentiations for this. If you differentiate this with respect to x, you will end up here. You will end up this. Okay, now we have just finished differentiating this. That's all. Right? We have not obtained the dy dx yet. Right? I hope you are clear how to differentiate that tangent inverse. Okay. All right. Now, of course, some of you may not like to use this method at all. There is a shorter way to remember this. Okay. Now I'm going to show it to you here. I'm going to leave that out for reference. So next time, whenever you want to differentiate this, consider. I'm just saying that consider y is equal to tangent inverse x. How do we differentiate this? Your dy dx is equal to 1 plus tangent x. So this is kind of a derived formula that you can use in the exam. Okay. Now, because your x is not just x, it's x over 2, right? So therefore, for this case, for the dz dx is basically 1 over 1 plus x over 2 square. All right, so now you will see where that number actually come from. Yeah, okay. So 4, 2, yes, correct. All right. 4, 2. All right. So this one, there's another half here, sorry. Yeah, because this one is actually the differentiated here. Mhm. So from here, this is where you get a 2 over 4 plus x squared. All right. Now I hope that is clear. There are a few sections that you might need to work on your own. Right? We can discuss more on that. All right. So you can either use the formula itself. I would say use the formula itself, or you can derive it manually. My advice is derive it manually. Okay. So I'm going to write down the answer here. What I have now at this point is dz dx is actually 2, 4 plus x squared. Now that's my answer for dz dx. So therefore, for y equal to x half x like this, I can actually write it down as y equal to xz like this, because I let my z equal to this. dy dx, you can see that this is a product rule. So this is a product rule. Okay, so product rule is also called the tecton rule. So you're going to differentiate one and then maintain the other one. Take for instance, I'm going to differentiate x first. If I differentiate x, it is the 1. So maintain the other one. Or I'm going to maintain my x, but I'm going to differentiate the second one with respect to x. Now you will see that this is basically the z. This is x. Have I found my dz dx so that I'm not very dizzy now? You have this. And then don't forget your z is basically tangent inverse x over 2 plus 2x over 4 plus x squared. All right. And then there you have it. Okay. You can also have your answer purely in term of x there. Now you're wondering at this point of time, is this the correct answer as compared to this? No, that is a very good question. Dun-dun. All right. Let's see. Let's see. I'm going to prove it to you. Both answers should tally. If they don't tally me that there's something wrong here, or there might be something wrong here. So checking. Okay, for checking purposes, now all I need to do is I'm going to use this equation here for checking. Dy dx is actually y divided by x. My y is actually this. So I'll substitute this into here. Plus x over 2 cosine square y over x. And then you will see that this is basically just tangent inverse x over 2, which tally here. And then this is x over 2 cosine square y over x. And then you will see that this is basically tangent x over 2 plus x over 2. Cosine we can write as a secant square y over 2. Oop, y over x, not y over 2. Yeah, you can actually write it down like this. And then the best part is here. The best part is here. Okay, we know that from here itself, the okay, I'm going to write down here for reference. So we know that y is equal to x tangent x over 2 here. Therefore, um, therefore, what should I say here? Therefore, tan y divided by x must be equal to x over 2. You can see that this is actually x over 2. And then by using trigonometry identity, 1 plus tangent square theta is equal to secant square theta. Okay, I can conclude my answer now. That will be the same as plus x over 2. This will become 1 over 1 plus tangent square y over x. And then what is tangent of y over x? Is x over 2. So x over 2 square. Okay, so this is actually x over 2 square. X over 2 square, that is a 4. Multiply with this, then you get a 2x. And then there's a 4, there's a plus x square. And then there you have it. Both this answer and this one are exactly the same. It's either you leave your answer explicitly, sorry, not explicitly, you leave your answer implicitly, or you can obtain your answer explicitly in x, in term of x. Right, now I hope this is clear. Yeah, of course you can go ahead and challenge yourself further on this. We can do more discussion on this. Right? Okay, now I hope that is clear. Okay, now where? Okay, this is where we are. The tangent to the curve. Yep. Don't forget, I'm going to rewrite my dy dx one more time. Okay, my dy dx is actually tangent inverse x over 2 plus 2x 4 plus x squared. Now there's my dy dx. Second question B. The tangent to the curve at the point where x equal to 2 meets the y-axis at the point with coordinate 0, comma p there. We need to find the p's. So the tangent to the curve at x. Therefore, we are going to obtain the gradient of tangent in this case. M is actually equal to dy dx by substituting x is equal to 2 into here. Now tangent inverse, that is basically tangent inverse of 1 plus, all you need to do is just put 2 inside here. So there's a 8, there's a 4, so a half there. And then tangent inverse 1. Tangent inverse 1 is basically pi over 4. It's actually 45 degree. Okay, 45 degree. Now that will be pi over 4 plus 1 over 2 there. Just let me check whether there is a 2. 4, 8, 2, 4, 4, 8, 1, 2. Yep. Now that will be the gradient of tangent. And then the tangent now, to work out the tangent itself, I might need to know the point where the tangent is located. So I need to know the y value for the point where the tangents need to be located. When x is equal to 2, I need to figure out my y. My y is given by tangent inverse x over 2. So that is simply tangent inverse a 1, which is pi over 4, pi over 2. Okay, so now I'm ready to obtain the equations for tangent. So the equation for tangent is given by this, the gradient. Okay, and then yep, up to you how you want to see this. Okay, now the equation itself, okay, up to you how you would like to see this. Okay, maybe I'll write it down in the intercept form. That will be a pi over 4 plus a half x minus pi over 2 minus minus plus a 1 plus a pi over 2. Did I get it correct? Just let me see here. Negative half, negative 1 there. Yeah, correct. So it's just negative 1. Therefore, y is equal to pi over 4 plus half x negative 1. Okay, that's the tangent. Okay, this tangent meet the y-axis. So at y-axis, the x is equal to 0. So you let x equal to 0, y is equal to negative 1. Therefore, the p value must be equal to negative 1. Now I hope that's clear. Okay, now I'm going to move on to the next one now. Okay, question 5. Okay, question 5. All right, by first expressing the equations, tangent equal to this as a quadratic equation in tangent theta, solve the equation. All right, now let's see whether we are able to solve these equations. Okay, now first of all, we have to apply some of the compound rules here. So first of all, tangent theta, we're going to apply compound rules for a compound angle identity for this, which is tangent theta plus tangent 45 degree over 1 minus tangent theta tangent 45 degree is equal to 2. Okay, now this one is a cotangent. So cotangent is basically 1 tangent 2 theta there. Okay. So in order not to complicate this, okay, this tangent 2 theta here, tangent 2 theta is, I'm going to write down here, it's actually 2 tangent theta 1 minus tangent square theta, right? So if I were to put this one in here, all right, so therefore I should be able to get 1 minus tangent square over tangent theta. I hope that is clear. And then simplifying this will be tangent theta. Tangent theta, this is actually a 1, so 1 plus this is a 1, so 1 minus tangent theta is equal to 1 minus tangent square theta over tangent theta. All right, so there's a lots of work to be carried out here. Okay, now since the domain has been restricted to the first quadrant, I would say. Okay, so the first quadrant itself, because it is restricted to the first quadrant itself, so therefore all the value for tangent must be positive. All the value for tangent must be positive, right? So since it is positive, I can sort of simplify this equation before doing anything more bizarre, for instance. So in this case, I can write that down as 1 plus tangent theta, 1 minus tangent theta. This one can be written as 1 minus tangent theta, 1 plus tangent theta over tangent theta. You can see that we can actually reduce this section here, knowing that the domain is within the first quadrant. Okay, then it's safe to confirm that these two values would not be 0. Right, it will be positive value, so therefore we can cancel that off. And then by doing a bit of algebraic manipulations here, I should be able to get myself 1 minus 10 square now. Okay, so this is where we are right now. Okay, right. Then of course you can the easiest way is to expand this properly. Okay, so that's what we have. We will end up with tangent theta equal to a half. All right. So by first expressing this in the tangent form, so I have already expressed this in the tangent form. Okay? And then thereby I'm going to solve this. The tangent will be the inverse of half here. Okay, now inverse of half. Let's see my calculator here. Inverse arctangent. So we have a half here. So therefore, it will give me now in terms of degree here, that will be 26.6 degree. All right. Now I hope that is clear. There's a lots of consideration whenever you attempt any mathematical question. So do keep your mind open to all possibility. All right. Now do comment if I miss out anything. All right. Okay. So we are done with this question. We're going to move on now. Okay, they leave a lot of space for us to write. Okay, which is good. Okay. Okay, now next. By sketching a suitable pair of graph, show that the equation has exactly one real root. Exactly one real root. Suitable pair of graph here. Right. Now, the suitable pair of graph that I can think of is, okay, I would say in this case, okay, let me get the cross here. So suitable pair of graph that I can think of at this point of time would be, okay, yeah, before that, let me label this as y, this is x, 0 is here. Okay. Now, the pair of graph that I would think of that you can get easily is y equal to x5 and a linear graph. Okay, plotting the linear graph is uh, quite easy. So all you need to do is just 1, 2 roughly. So even though I did not draw with scale here, but I'll try my best to draw it so that it looks logically correct. Okay. Now that would be my graph y equal to x plus 2. Okay. All right. So I hope that is clear at this point. Okay. Now the second graph would be y equal to x5. That is harder to draw at this point. We know that this graph definitely passed through the origin. Now as x increases, because this is the power of 5, it will increase. It would increase tremendously. As x increase in the x direction, it will also increase tremendously. So therefore, the shape of this graph would look something like this. Yeah, that would decrease tremendously, and then at the same time, it would increase tremendously also here. So therefore, we can conclude that there is an intersection, and then this would actually give us exactly one real roots, because it's impossible for these two graphs at this region here to meet, because this increase more uh, aggressively, right? So there's only one real root. Okay, I hope that's clear at this point. Yeah, I forgot to label this. This is a graph y equal to x5 here. Okay, now since we are done with this, now next. So based on the graph just now, we have a positive real roots. Okay. Okay. Now next we need to show that if the sequence of values given by the iterative formula converges, then it converges to the root of the equations in part A. Now all we need to do is just rewrite this one more time as, okay, now hold on, rewrite this one more time in terms of x. Okay, write it down in terms of x without using the iterative notation. And then we're going to manipulate this algebraically, and then to check to see whether we are able to reach a conclusion that we have x5 is equal to x plus 2 here. If we can, then it means that this iterative formula converges and then will be able to allow us to obtain the same root as this equation here. Okay, now let's give it a try. If I do that, there will be a 5x5 minus x equal to 4x5 plus a 2 here. And then you can see that there is actually a x5 equal to x plus 2. Yes, because it's the same as the original equation. It is equivalent to number 1 there. So therefore, we can conclude that this xn plus 1, 4xn5 plus 2 over 5xn4 minus 1 converges. Converges means it will be able to obtain root. In this case, converges to the root of equation 1 in my case, which is equation A. Alright, so I hope that's clear. Now we're going to move on next. Okay, using the iterative formula that we have just now. So the iterative formula is n plus 1 equal to a 5x and 5 minus, let me see, is it minus a 1 minus a 2 over 4x and 4. Is it plus a 2? Let me see. x5 minus minus a 1. So there will be an x plus 2. Okay, this is a plus. Yeah. So this is the iterative formula that is given above just now. So using this iterative formula here, iterative formula number 2 here, with the initial value of x1 equal to 1.5, we need to calculate the root correct to 3 decimal places. So all we need to do is we are given x1 equal to 1.5. Now all we need to do is determine the x2. So x2 is basically just x1 to the power of 5 minus 2, 4x1 to 4 minus 1 here. And then we should be able to obtain the value here. So just let me get my calculator here. I think it's better if I set it to a spreadsheet. It'll be easier for me to calculate in this case. So I will have my 1.5 here. Okay, 1.5. Then the next one will be okay. So the next one will be here. I will take I'll take this. Let me see here. 5 to the power of 5 here. Subtract off it 2, and then divide by the 4 times the same a here, the same a here, Okay. Raised to the power of 4 instead, minus 1. Okay, so that will give me the first number. Calculate the roots correct to 3 decimal places. So if it's 3 decimal places, then your intermediate calculations should leave it to maybe 4 or 5 for much accurate answer in this case, right? So therefore, next this will be this answer here. Okay, and then let's look at the second one. All right, the first one is here. So the first answer is mm, 1 point to calculate the root. Okay, 1.86 851 for instance. Right now, this is the intermediate answer. It's not the final one yet. Give the result of each iteration. Oh yeah, they have already given us the instruction. 1 2 3 4 1 2 3 4 5. Okay, that's good. Now, therefore, your x3, using the same formula, based on my calculator here, we should be able to obtain 2.34266. And then by continuing further, okay, that will be the same as this, and then I would be able to obtain my x4 here to be 2.9361. Okay, 9361. Then I'm going to proceed on further. I'm going to get that I have here. Okay, x5 is 3.67576, and then I'm going to proceed on further. And then let me see, what do I have? 4 point something. Let me see what do I have. I just drag it down so it's easier for me to see if I'm able to obtain an answer for this. Okay, it doesn't seem to work here. Okay, hold on. 27 something. Is there anything wrong with my formula? Hold on. Oh yeah, I accidentally put a minus 2. It's supposed to be plus 2. Okay, so this is plus 2. Hold on, just let me try this out. Plus 2 minus 1 to the power of 4 plus 2, 5. Okay, let me grab that one more time. Okay. Alright, in this case it does not looks very convincing. Let me check again if I miss out anything else. Okay, it does not converge. Why? Why it does not converge? Is there anything wrong with this? 5 plus 2 from A3, A3. Yep, this is correct. Okay, just let me try some more. Interesting. It does not converge. Why it does not converge? 1.5. Okay, just hold on. Let me check back the original iteration if I got this correctly. Oh, now I spot my error. You see that? I assume that is 4. Yeah, correct. So the 4 is supposed to be on top, the 5 is below there. Okay, it's cool. All right. So recognize your mistake is something that we need to learn. Okay, so this is 4, this is 5. All right. So sometimes it's good to check. You will notice that it does not converge. There must be something wrong somewhere there. So this one's is 4. This is 5. Oh yeah, it's supposed to be that way, right? No, that's my mistake there. I forgot to check. This is supposed to be a plus. Okay, a lot of mistake there. Okay, from here I need to correct my formula one more time. That will be a 4. This part will be a 5. Okay, so let me check that one more time. Sorry, let me check that one more. Yes, correct. Okay, this time is correct now. All right, so my second iterative would be 1.33162. Yeah, and then my third one will be 1.27352 here. My fourth one, this is my third, this is my fourth, 1.27352. X5, this is 4, this is 5. Okay, that's 1.26724. My X6, okay, my 6 is 1.26724. Right. Now it looks as if it's stabilized already. But then again, if you go to a 7, it soon go to 1.26717. X8 is 1.26717. Now, when it reach a saturation point, you can see that to the nearest 5 decimal places, the iterations would tend to converge to this root, and then we have to leave the answer for the root to the nearest 3 decimal places. So the roots is 1.267, nearest to 3 decimal places. All right, now I hope that is clear. Hope that you recognize all the errors that I have committed, okay, for your own learning. All right. Okay, now that is cool. We are done. So now we're going to move on to the next one. All right, next one, 7. Okay, question 7. Let's see. You're given this function here. We need to express fx in partial fraction. Okay. So first thing, when you recognize this, you check the denominator. What types of factor are you having? It's a linear factor. So therefore, we can write this partial fraction in this form. Okay. And then, of course, we can combine this as a 2x plus 1 plus b minus 1, sorry, divided by 2x minus 1, 2x plus 1 here. Okay, so there you go. By comparison, you can see that denominator is the same. Therefore, we can conclude that the numerator must be the same as 2 here. Okay. Now, there are many ways to actually do this. Okay, all right. You can do it in such a way through substitution, for instance. So if you substitute a half, okay, so if you let your x equal to a half, so you're going to substitute into this equation here. So when it's a half, this term is gone, so b is gone, and then you have a half is a 2a here is equal to 2. Therefore, your a is equal to a 1. Okay, and then if you let your x equal to negative half, then this part will cancel off, and then that will be a negative 1, negative 2, negative 2b is equal to a 2. That implies that b must be equal to negative 1. Therefore, fx can be written in its partial fraction this way: 1 over 2x minus 1. B is 2x plus 1. Now it's always good to check if you combine this. Okay, mentally just let me check that is a 2. Yep, correct. So always should check if you combine them, will you get this? Yes, we do get this. All right, now I hope that's clear. Gonna move on to the next one. 1 1. Okay, now using your answer in part A. Okay, so the answer in part A, is that okay, this time I hope that I got it correct. Let me see. It's 2x minus 1 minus 1 plus 2x plus 1 here. 2, 2, 2. Yeah, correct. This time is correct. Okay. We are going to get the square of this. All right. So the square of this simply means a square of this. Okay. So if you square this, you will get 2x minus 1 square minus 2 minus 2. What do we have? Interesting. Minus 2x minus 1, 2x plus 1, and then of course plus 2x plus 1 squared. It's a normal quadratic expansion. You can see that we have obtained these two. Okay, now the center one. Okay, now the center one looks the same as fx actually. This is actually fx, so therefore we can rewrite this as okay, fx is 2x minus 1 minus 1 over 2x plus 1 bracket okay. So from here we will have this one here, and then by rearranging this correctly, plus 1 over 2x plus 1 square. And then let's check. Okay, cool. We have already proven that. Right, now I hope that is clear. All right, next. Where are we? Hence, okay, the chicken and egg theory. So hence, the integration for this, I just rewrite one more time. This is basically 2x minus 1 square minus 1 over 2x minus 1 plus 1 over 2x plus 1 plus 1 over 2x plus 1 square. Therefore, integrations of the square of this with respect to x from 1 to 2 will be given by here. Okay, so there's a long integration here. Hold on. Okay, that's how we are supposed to integrate this. All right, now the integration shouldn't be that tough in this case. So we can use a standard formula for this. So therefore, this is actually what do we have here? 1 divided by 2, so it's actually 1 over 2, 2x minus 1. Yeah. And then now from here we have this one is actually half a ln 2x minus 1. So it's a ln, it's a half. And then this is a half ln 2x plus 1. And then again, this is the same thing here. Did I do something? Oh yeah, correct. This is supposed to be negative. I forgot that. Now the same thing, it will be negative also. 1 over 2 also, 2x plus 1. Okay, so right here all we need to do is just substitute all this value. Okay, just let me check if I got everything's correct. Negative 1 over 2. Yep, okay, that's cool. So from here all I need to do is just yep, okay. Hold on, just let me check for a while. I can always simplify the whole structure here if I want. In this case, I can actually take out negative half. Now that will be okay. That will be 1 over 2x minus 1 plus 1 over 2x plus 1. And then these two also I can simplify that, combine them together. So 2x plus 1 over 2x minus 1 like this. Okay, now might be easier to substitute. So all I need to do is just put in 2 here. So if I put in 2, I'm going to write down my working in the side here. So if I put a 2 here, there's a 3, so negative 1, 2, 1 over 3 plus a 2 here, 4, 5, plus 2, a 2, a 5, a 2, a 4, a 3. Okay. Alright, now that's the first part, and then when I substitute a 1 inside, so this is when x is equal to 2. Now I'm going to go for x is equal to 1 here. Okay, so when x is equal to 1, I have negative half. That is a 1. That is a 3 plus a 1, a 1, a 3, a 1, a 1. So there's 3 here. Okay. Now let's see what do we have now. So therefore, from here, right, I will have this one here, subtract. So therefore, that is this 1/3 plus 1/5 plus half 1 plus 1/3 here. Okay, and then I have a half ln 5 over 3 subtract half ln 3 here. Okay, so from here, let me see what do I have here. That part is gone. I will have a half. I have a half of 5, a 4. Is it 4, 2? Let me see. Half of 1. Okay, so if I simplify this, when I take a half there, 2. Okay, so that is is it correct? Oh yeah, that's gone already. So here I'm going to take out that 4, 5. Okay, so that is a 2, 5. So if I simplify that, there's a 2, 5. And then this part here will be half. So that will be ln divided by 5 over 9. Yeah, correct. So it's 5 over 9. And then therefore, yes, hence the chicken is able to lay the egg here. Okay, so I hope that's clear. Alright, now next. How many questions left? I sort of lose track. Okay, now next. Right. Vector. Okay, vector question. All right. Now, relative to the origin or the points ABC have position vectors given by this. Now, the Fourth point C is such that ABCD is a parallelogram. Find the position of the vector C and verify that parallelogram is not a rhombus. Okay, so it's not a rhombus. Um, because it's not a rhombus, just to recap, rhombus is the types of parallelogram where it has the same equilateral, I would say equilateral sides. All these sides are the same. So that will be a rhombus. So we want to check whether that is a rhombus or not, or whether it's just a typical parallelogram. Okay. So first of all, we have now I'm just drawing on a flat two-dimensional space here. Okay. So you have point A, B. Okay. So point A. You have point B here, for instance. You have something like point C here. You have like something like point D here, and then sort of they are parallel to each other. Mm. So just based on this orientation, most probably this will be parallel to this. This will be parallel to this. Okay, so this is how it look like generally. Now point C. Okay, now one easiest way to obtain point C. Now, of course, you can use your geometry coordinates methods, or you can use vector method. To use a vector method, we will have to create a line CD here, line CD, and then we have to create a line BC here. You will notice that this both of these lines intersect at C. So by solving this simultaneously, we should be able to deduce the intersection between the line BC and CD there. So we are going to do that. For line CD, okay, to work out line CD, the equation is here. Okay, I'm going to write down R1 here. We need a point. For a line, you must have a point. Since we have the point there, which is a D, D is actually 302. Okay, be very mindful with this. So there's 302. And then let's use a parameter here, and then it must have a direction. Since BC AB is parallel to DC, so we can say that the direction of CD must be the same as directions of AB here. So if we work out the directions for AB, okay, now I'm going to work it out at the side here in case you're wondering how do I actually come up with AB. AB is basically OB minus OB minus OA in this case. Okay, so if you take this one here, it'll be 1 negative. Oh, sorry, where is the negative? It's positive. Okay, hold on for a while. It's a positive 3. Yep. So it's a positive 3, and then there's a 2, 3, 1, 2, 1. Okay, that's a nice number there. So therefore, it has this direction here. All right, that's my first line, CD. Next, I'm going to determine the line BC here, R2. So the line BC must pass through B instead. So 2, 5, 3 here. You can use another parameter because they are of different lines here. Okay, now the directions of BC is the same as directions of AD. So I'm going to work out my directions for AD. So AD is OD minus this. That will be a 2, negative 2, and then a 1. Now there will be 2, negative 2, 1 there. Now because lines CD and BC intersect at C, therefore R1 vector must meet at with R2 vector some way. So by resolving its component, you can say that 3 plus lambda must be the same as 2 plus 2 lambda. 3 plus lambda, is that correct? Yeah, correct. Is that correct? Just let me check for a while. Yep, correct. Okay, so from here, I can write down lambda minus 2 mu is actually -1. Okay, that's my first equation. And then after that, I can have my 3 lambda is the same as 5 minus 2 mu there. 302. 302, it passed through a D. Oh yeah, it passed through a D302. Yep, correct. You're right. Okay, so from here we have what do we have here? We have 3 lambda plus 2 mu is equal to 5. That's my second equation. Now we're going to solve this. Solve 1 and 2. Yeah, of course, by solving 1 and 2, I will have my lambda equal to a 1. It's very obvious. You will be able to get a 1. And then after that, from either one of this equation here, your mu would be equal to, let me see, that would be a 2. The mu will be a 1 also. Or mu will be a 1. Then for checking purpose, whether they actually meet these parameters is to check the last term. So the last term we have 2 plus 2 lambda. 2 plus 2 lambda should be the same as in this case is 2 plus, if my lambda is 1, so therefore there must be a 4 there. And then the other one is 3 plus mu. Mu is 1, so that's also a 4. Okay, so which means this answer is correct then. Knowing that this is correct, okay, the final sections will be to recognize the position vector. So the position vector for all C now, position vector for all C, you can substitute either one of these parameter back to either one of this. Okay, take for instance, both of them are also 1. So maybe we put a lambda 1 here. That will be a 4. That will be a 1 or 3. And then that will be a 1 or 4 again. Now that will be the position vector for C. Right? Now I hope that is clear. Now we still need to verify that the parallelogram is not a rhombus. So one way to do this is to check the magnitude for AB first, and then to check for the magnitude for BC, whether they are the same length. If they are not the same length, then we have managed to prove that this is not a rhombus. Okay, let's give that a try. Since now we have found the position vector, so which is this. Is that correct? 2, 2, 2. Yep, correct. Okay, so I'm going to erase all this. Okay, so at this point, what we need now is just the magnitude. So to get the magnitude is quite simple. AB magnitude. So AB magnitude is basically a 1, 3, 2 magnitude. So 1 square, 3 square plus 2 square. This is what, 13, 14. Okay, 14 units square. And then BC. Okay, BC, BA. Okay, BC. All right, BC, that is a 2, -2, and then a 1. Okay, this is actually a 3 unit. That's actually a 3 unit. Okay, 3 unit. And then of course, if you want, you can verify the AD if you are interested. Okay, so like for AD itself, you can verify that quite easily. Okay, 2, -2, and then a 1, which is actually 3 unit, 4, 4, 8, 9, 3. Okay, and then finally you might also interested to verify CD, for instance. Do you think CD would be the same length as AB? Okay, CD, where is CD? Okay, C and D. There is a 1, there's a 3, and definitely there's a 2. Okay, now there is a 1, 2, 3, 1, 2, 3. It must be 14 root. Okay, so here we can verify that quite easily. This is the same length as this. These two must be the same length. BC is the same as AD, whereby the CD is the same length as AB. All right. Now that actually verify this is not a rhombus, because length AB is not the same as BC. Therefore, it is not a rhombus. All right. So I leave that to you. I hope that's clear. Okay, we are done. Oops, just let me keep the rhombus there. We might need it. Not the rhombus, the parallelogram. Okay, just let me repeat that drawing one more time. Just give me a while. Does it come out? Okay, it does come out. Okay, I'm going to erase off this part here, which I don't need. Okay, which I don't need. Okay, that is the part that I might need shortly. All right, now next we need to find the bad angle. The bad angle. All right, now find angle BAD, which is this one here. Now to find the angle BAD, we should be let theta be angle BAD then. Okay, that's the one that we want to find. We know that from the scalar product, cosine is given by this dot with AD divided by its magnitude. Okay, now we have verified its magnitude just now. This one here is 3 unit. Okay, and then we're going to work this out first. Dot product with AD. Okay, AD. Okay, this is tough because I can't recall the coordinates there. So let's come back here and refer back to this coordinate so that we can use it down there. So this is like a 1, 2, 1. B is 2, 5, 3. This, okay, CD is there. All right, now we are good. Now let's go back here. Okay, now we are ready. BAD, so AB dot product with or scalar product with AD. So AB is what do we have here? We have 1, 3, 2. The scalar product with AD. AD here is 2, negative 2, and 1 here. Okay, that will actually give us a negative 6 plus a 2, which is a negative 2 here. Right. So from here, cosine theta will be equal to negative 2 divided by root 14 by a 3 there. Okay, and then from here, yeah, this is a negative value. Is it? Is the angle very big? Okay, let me see. So in this case, most probably this is an obtuse angle. So let me get my calculator here. So what do I have here? I have the arc cosine negative 2 over, hold on, can't see that, 3 square root of 14. Okay, that is approximately 100. So I just leave it as 100 degree. All right, now that is the angle BAD. I hope that is clear. All right, okay, so we are done here. I'm going to keep that. We might have the extra questions down there. All right, now area. Okay, area. Okay, area of the parallelogram. Right, now this area of this parallelogram, right? Area. Now let me show it to you here. Let me redraw this one more time so that you can see it more appropriately in this case. Oops, I think I drew it wrongly. I think it's supposed to be something like this. Yeah, it's more like something like this. This is theta. This is A, B, C, D here. Right. Now, one way we can calculate the area of this rhombus is by using this formula here. So the area rhombus, sorry, area of parallelogram is by using this formula here. AD, we just need to determine the length for AD, which we have already found out 3 unit, and then multiply that by the perpendicular distance from B to here. Okay, right. So I hope that's clear. Now, perpendicular distance D can be calculated using this. D is basically AB, AB, AB cosine alpha. AB, oh sorry, AB cosine alpha, my bad. AB sine alpha. Yes, AB sine alpha. Okay, AB sine alpha. But we don't have alpha. We do know that sine alpha is the same as sine 180 degree minus theta. And then through identity, we know that this is exactly the same as this. Sine theta. Okay, I hope that's clear. All right. And then this is exactly the same as the vector product between AD and AB. Right. That will be the vector product. Okay. So the vector product for this would be AD. So let's look at AD. AD is 2, negative 2, 1 cross product with AB. Okay, AB is a 1, 3, 2. Magnitude of this, right? Okay, so I hope that you still remember how to cross product this. Okay, if I do it correctly here, I should end up with, let me see, negative 7 here. Is it negative 7? Yeah, negative 7. The second one, 4, 3, negative 3. 4, 3, negative 3. And then the last one is 6, 6, 8. So I have 8 here. Magnitude of this. So the magnitude of this is actually 7 square plus 3 square plus 8 square, square root. Alright, so just let me try to use my calculator to get this, to see whether that is correct. Plus with 9 plus 64 is easier. 2, 2. So 11.05. 11.05. So that is approximately 11.05 unit square there. All right. So I hope that's clear. Do revisit this vector product in my other videos. Okay, we are done with this. I think we still have one more questions. Yeah, I think this is the last one. Or is it? Okay. All right. Now, complex number u and v, u and w are given as such. Find u and v given your answer in that particular form. Okay. Now, there are many ways to solve this. Okay. Take for instance, my personal way, I would actually do it. In this case, we will let u be x plus iy in this case, x plus iy. So therefore, this would be x plus iy minus, okay, minus w. Am I? Oh, hold on. Sorry, I misread that. U and w is in this form. Sorry, my bad, my bad. I should be using the original one here. So u minus w is equal to 2i. And then knowing that uw is equal to 6. Okay, so I can use substitution to solve these two equations simultaneously. So take for instance, by using u equal to w plus 2i, so there is w plus 2i here, w, yeah, so u is actually w plus 2i, and then it's equal to 6 here. Okay, so from here you get omega square, and then 2i w minus 6 equal to a 0 here. Therefore, omega by using the quadratic formula, so we have plus or minus 4i square plus 24 here over 2. Okay. Okay. Now from here we have negative 2i plus or minus, you can bring what, let me see. You can bring the 4 out. Yeah, I think you can bring the 4 out because this is actually negatives. This is actually negative 16. All right. Now knowing that your I square is actually equal to negative 1 for any complex number. So I square is negative 1, so this is actually negative 16. So negative 16 there. So it must be 8. Square root of 8. So square root of 8 is actually 2 sub 2 here over 2. Therefore, we can sort of simplify this as a sub 2 plus or minus sub 2 minus an I. Okay, so that is our W. So if we let W equal to sub 2 minus I, therefore U must be equal to negative sub 2 minus I then, right? Because this is a quadratic equations. So therefore the roots for these quadratic equations are always a pair of conjugates, right? Or of course, or you can let u equal to this, whereby omega will be negative sub 2 minus I then. All right, now I hope that is clear, where x and y are real and exact. So x and y are real and exact. So you can see they are real and exact. All right, so I hope that is clear. 2 with I. Okay, let's move on to B now. Okay, on a sketch of Argand diagram. Argand diagram is just another different perspective of Cartesian coordinates. Shape the region whose points represent complex number z satisfy the inequality below here. Okay, now let's try to get the correct perspective on each one of these. This is basically a region uh, within the circle itself, centered. So this is actually a circle centered at the coordinates of 2, 2, 2, 2, 2. Right? So always rewrite this as z minus 2 plus 2i there. So from here you can see that right now this is the center, and then this part here will be the radius centered at this with radius of 2 unit. Okay, all right. Now the rest here is mostly a region below and above a straight line. All right, and then we are going to look at this shortly. Okay, now first of all, let's set up our Cartesian here. So hopefully I got this correct. This is Argand diagram, so you have your imaginary here, you have your real section here, just a different label. This is circle centered at 2, 2, so let's assume that 2, 2 is somewhere here. 2, 2, this is 2, this is 2, and then 8, 2, set 2. So this is 2, set 2. 2, set 2, that is a radius of 2 there. Okay, hold on. So let me draw that more logically. So maybe somewhere here, for instance. This is a 2, 2, 8, 2, 2, set 2. So it's more than that. All right. So therefore, this is actually a circle. All right. So I'm going to redraw this. Let me see. This is a 2. So you can see that this is actually a 2. This is actually a 2, 2, 2 here. All right. So it's actually a circle. Hopefully I drew this correctly. Sorry for my drawing, it's just a rough sketch. So that's a circle with a radius 2 unit. All right, and then because it is equal to, so it's basically the area within and including the circle itself. All right. Now next, the argument. The argument of z. Argument of z always start from the origin, and then is more than 0 and less than equal to 45 degree. So less than equal to 45 degree, it should be here. Okay, so that will be the region. Okay, it's more than, so it's here we draw it, it's more than 0 but less than, so you are looking at all the region down here. Okay, now I'm going to sketch that. So let me sketch that so that you can see. So the first region is all here. The second regions are all here. Starting from here. So that is the region. Okay, you will see that there's overlapping here. Okay, now the last one, the real part of z is less than 3. The real part of z. So the real part of z is less than or equal to 3, meaning that you can see the real part. This is the real part here. So if the real part, okay, now I'm going to show you a bit of the algebraic equations here. So the real part of z is less than or equal to 3. Basically, it means the real part of a plus ib is less than a 3. So you are looking at a is actually less than a 3 because a is a real part, which means the x component must be less than 3 here. So first of all, this is okay. Now let me see where we are here. Where is the 3 magnitude 3? This is actually let me see. What is this actually? Is this a point? Is that a point? Okay, or is that that is basically the x value is a 3. X value must be a 3, but the y value doesn't matter. The y value doesn't matter. So we are going to locate where is x equal to 3 here. Okay, so let me see here. This is actually 2 unit. Okay, this is actually 2 unit because it's a radius from here. Okay, and then therefore from here I'm going to make a okay. So from here this is like 2 cos 40. That is set 2 here. So this is actually set 2. That's 3 point something, right? So up to this point here is this is actually okay because this is 45 degree. This is a 2, and then this one must be 2 plus 2 cos 45 is set 2 so plus. Okay, so this is actually 2 plus set 2 from this joint here, and then they are interested with 3. So 3 is somewhere here. Okay, I'm not really drawing that accurately. So the 3 is somewhere here. So I'm going to draw a straight line. This is actually a straight line, a 3. Hold on. Oops. Hold on. Let me get a different color so that we can see the difference here. Okay, so a 3. So basically, this is this represent oops, that represent a straight line. So this part represent a straight vertical straight line. Right, so it's actually a vertical straight line. You can see that. This is basically x equal to 3. Okay, x equal to 3 all over here, right? And then it should be less than should be all this side. Are you able to identify all the overlapping between the blue, the green, and so on? Yeah, it shouldn't be tough to recognize that. All right. So the region that we are talking about is actually here. You can see that from here, and then from here is so this is a region that we are supposed to be shading. Alright, now of course I might make a mistake along the way. Do comment in my video if there's any error there. So on the sketch of a Argand diagram, okay, shade the region whose points represent complex number z satisfy the inequality. So the final shading is over here. Now just let me reiterate again. This is actually a circle. This is actually a straight line also, starting from the origin itself, whereby this real z is a vertical straight line, x equal to 2. So that is our final locus or region where our solution is located. All right, now I hope that's clear. Okay, let me clean up and let me see whether I have fully completed all the question. No, I have not completed. I still have one more to go. All right, so let's look at this. I just have to finish off all this. Okay. Now, a tank containing water is in the form of hemisphere. Okay, that's hemisphere. The axis is vertical. The lowest point is A, and the radius is R in the diagram. The depth of the water at time t is h. At time t equals 0, the tank is full, and the depth of the water is r. Okay. Now, at this instant, a tap at A is open, and the water begins to flow out at a rate proportional to h. Okay, to h. The tank becomes empty at time t equal to 14 there, right? Begin to flow out at a rate. So the water begins to flow out at a rate. At this instant, a tap is open and the water begins to flow out at a rate that is proportional to h here. Empty at time t equal to 14 there. Now the volume of the water in the tank is V when the depth is h. So it is given that V is equal to this. All right. Now we need to show that H and T satisfy differential equations of the form here. All right. Now I think at this instant the water flow out. When they say flow out, I assume that the rate of volume is directly proportional to h. Right. But rate of flow out, because it's flow out, it must be a negative sign here, right? And then the connections between dv dt using chain rule. We know that dv dt is the same as dv dh by dh dt here, because the h would be reducing at a certain rate here. Right, so the depth is here. Let me see any other informations given. Yep, so generally that's how it looks like. So from here, all we need to do is equate these equations with equations number 2 there, and then we should be able to obtain that. Okay, just let me check what do we have. So from here we are given V, right? So dV dh. So if I were to differentiate this with respect to h, I should be able to get pi over 3 with respect to h, right? Yeah, correct. So there's a 6rh 3h squared. So if I were to simplify that, that will be a pi a 2rh minus h squared. Okay, and then therefore, with all these informations from number 1 here, I can write that down as pi 2rh minus h squared by the rates of change in the height must be the same. If I were to convert this to equation, it must be this, where I would say that this is a constant real number. All right. Or b is a positive constant. Okay, so they use a b. B is a positive constant. Okay, so since they use a b, I might as well use a b then. Hold on. So since they use a b, I will follow their requirement. That will be a b h here. Okay, so from here, we can conclude the rate of decrease of the height is given by negative b h divided by pi 2rh h squared. And then there you have it. you can simplify this. That will be equal to negative b pi 2r, and then let me see here. If you divide by this, that is a h half, and then there is a h 3 over 2. Okay, so I hope that is clear here. 2RH, yep, 2RH, yep, correct. Okay, now yeah, in this case the b that they are using is very different, sorry, my bad. Okay, let me correct that. Okay, I'm supposed to use a k. Keep on changing my mind. Not very good in the exam. Okay, but never mind, it's a learning journey. So I would start by letting that as a k, where the k is all real numbers here, positive real numbers. Okay, positive real numbers. So that will be a k in this case. Now I know that k divided by pi is another constant. So um, therefore I can conclude that. Therefore I can conclude that negative b over this, where the b where b is equal to k over pi there. And then therefore I managed to prove this, right? I hope that is clear at this point. Okay, are we done? Oh, we still have one more. Yep, we still have one more, I think. Okay, so from here we have our differential equations. dH dt is actually equal to negative b 2rh half minus the h 3 over 2 there. Right. Now we need to solve the differential equations and obtain expressions for t in terms of h and r. Right. Now we know that the container is empty, right? The volume is equal to 0 and the height is equal to 0 when t is equal to 14. I think it's 14 seconds. Right. Okay. So from here, we are going to divide and conquer this because they are separable differential equation. So this is a first order differential equation. They are separable. So I'm going to separate in such a way. All right, you can see that we can separate them. And then after that, we can perform antiderivative. Okay, so from here we have 3 over 2. 3 over 2 is 4 over 3. R is a constant. H3 over 2 minus 5 over 2, 2 over 5, H5 over 2 is equal to negative BT plus another C there. All right. Okay. Okay. Now from here we also know that okay, I'm going to write down some of the information. At t equal to 0 at the beginning, the height is the same as the radius as mentioned before. So at t equal to 14 seconds, the height is equal to 0. So we're going to use these two informations. At t equal to 0, so t equal to 0, h is equal to r. So therefore from here, we should be able to get the c. All right. So the c will be the r. That will be 5 over 2. So 4 over 3 r 5 over 2, and then minus of 2, 5, h 5 over 2. Okay, so that would be like, what do we have here? 20 and 6, 14, 15. Okay, so 14, 15 h 5/2. All right. Okay, did I get it correct? This is the h. Okay, the h. Yep, correct. Nothing wrong. And then this is a h. Okay, when h is, oh, sorry, my bad. It's supposed to be r. I have already changed it to r, but I still write down as h. So therefore, the final form here is supposed to be an r. Is that correct? Yep, correct. So r is here. Now, therefore, we can substitute this one in here. We will have 4, 3 RH 3/2 minus 2 phi H 5/2 is equal to negative BT plus 14 over 15 R 5/2. All right, now we are almost there. And then finally at t equal to 14, H is equal to 0. So H is equal to 0 when t is equal to 14. So therefore, here we can conclude that B is equal to 1 over 15 R 5/2. And then therefore, expressions for T into our H. Okay, so therefore we can rewrite this as RH 3/2, 2/5. This one is 1 over negative 1 over 15 R 5/2 T plus 14 over 15 R 5/2. Okay, so I think that's what we have. And then finally we can simplify this. Okay, just let me do a rough working on the simplification. So in this case, it'll be yeah, we go for 15 then. Okay, 5, 20, 20 RH 3/2. That would be 15, 3, 6 H 5/2. Okay, so that will be a negative R 5/2 T plus 14 R 5/2. Okay, and then finally I need to divide everything by R. So therefore, so if I divide everything by R there, I would be able to get T. So the final answer will be T is equal to, now that would be, divide that, so that will be, is that correct? 14? Yep, so 14 minus 20 R, let me see, negative 3/2 H 3/2 plus 6 R negative 5/2 H 5/2. Okay, or sometimes you can actually write that as 14 minus 20 H over R 3/2 plus 6 H over R 5/2. Okay, and then there you have it. We managed to describe T in terms of H and R. Now, I hope that is clear at this point. All right. Okay. Now, hopefully that is our last question. Let me check. Oh yeah, luckily that's our last question. All right, now I hope you enjoy this working here. Now do think about this paper here, and then have your own take on that. And then if you feel that there's anything else you need to discuss, uh, we will do that later. And then you can write your comment, or you can yeah, write down a comment, or any suggestion, or if you have point out any errors in my videos, I will be very happy to learn that from you also. Right now, thank you very much for watching. See you again.